Hello students, welcome back. Previously we completed OPT 1.3 and the result we got from there was the standard deviation of about 5.317. Yes, we could use 5.32 and this is what you're gonna get if you use the z-table, and that's fine with me. But here let's go with a little bit more accurate figure because it's available, and then in the end we're gonna round accordingly at the very last step. Okay, 1.4 and 1.5. Find the proportion of the cars that are traveling faster than 55 miles per hour. And we have to use the sigma value right here. 1.5, 5 the 95th percentile, again using this standard deviation 5.317. Okay, how does this problem compare with 1.4? The big difference is standard deviation 4.95 versus 5.317. Virtually the same deal. It's a repetition of the same problem basically. So let me go ahead a little bit quickly here. Here's the general scheme: outline, center, end, and shade. Here we go. Outline is usually provided. The center is, as usual, 62, and 55 comes to the left. Do you see it? It comes to the left because 55 is less than 62. And proportion of the cars that are traveling faster than 55, so shading is to the right. Okay, all right. Let's answer the problem here. What's the z-score? Z-score is end minus center over standard deviation. Did I get this right? 5.137. Is that right? Yeah, that's what I got from the previous problems. So let's use that. And let's ask Mathematica what this quantity is. And here we go. Negative 1.31 approximately speaking. Negative 1.32. Okay, all right. After the rounding, I have 2 decimal digits, so let's look up the z-table. So where's the z-table? Negative 1.32. Negative 1.3 is here. Negative 1.32. I'm getting this number, 0.0934. So the probability the speed is faster than 55. That's approximately equivalent to z-score greater than negative 1.32. And that's approximately, what is it? What did you find? 0.0934. So we have it. Is everything correct? Check everything. All good? No, something's wrong. Please check what's wrong. Look at the shading. I shaded the majority of it. So certainly greater than 50%. It should be majority. But I have less than 10%. So this red part doesn't look like just a 10% or less. Looks far more like 10% is over here. And indeed, if you go to the z-table, shading is always to the left. Here I have right shading. So this is incorrect. You see? This 0.0934 corresponds to here, over here, not there, the big region. So this is what I have to do. I have to subtract it from 1, which is the total area down here, and that's going to be approximately equal to, let's see, 0.8 9066. Oh, come on, why am I doing that? Yeah, okay, all right. Okay, there was no reason for me to do this mental math. I could have used my calculator. But anyway, it worked out. So, we have to subtract from 1. Remember, we went through a similar kind of exercises from the main lesson notebooks here multiple times. And of course, there are many like these in MyMathLab as well. The difficulty to this problem is basically the sigma part depending upon the previous problem. Otherwise, pretty much standard. Find the 95th percentile. Again, same standard deviation value we had before. Let's have a picture. The same idea, outline, center, end, and shade. And 95th percentile is, of course, much to the right here. And then the majority part, this part is 95%. So 95% of the cars are slower than this. So what is this x? Z-score is end minus center over SD. $317. And everything is approximation in statistics, so let's use Wrigley equality sign here. And then what's the z-score associated to 95th percentile? Well, we'll have to look it up. Where's 95%? Because all these numbers here, those are probabilities. And where's 95%? Right here. 0.9495 versus 0.9595. Push. And this one is 1.64, 1.65. So I'll estimate it somewhere in the middle, 1.645. So 1.645. So from here I can find out what x is. So x minus 62 is approximately speaking 1.645 times 5.317 if I flip this denominator to the other side. And then if I flip this 62 to the other side, then x is approximately equal to 62 plus this one we had before. And then that's approximately equal to, well, let's do this computation with Mathematica. You can punch in the calculator, of course. I'm getting 70.74 something. Um, 70.75. Okay, I'll stop there. Maybe I could do just 71 miles per hour to the nearest integer. I don't care. I didn't specify how many decimal digits I said you have to do, so I have a bit of a freedom here. I just decided to cut about here. Okay. I use a little bit more accurate figure. So I have a little bit different figure, but at the end it's about 70.75, the same deal as before.